Hi, everybody. I'm going to move on to page 8 in the math. So this is the second part of the packet, number 13. And for this one, you can see I started doing some work ahead of time because I didn't want to stretch out the video to have you watch me do all of this long division. But this asks, which of the rational numbers represents a repeating decimal? So the thing to notice here is that these are all fractions. And fractions are division problems. When you take the numerator, divide by the denominator, you'll get a decimal. So I started doing that to just see how this was going to work out. And of course, if you have a calculator, you can do this on a calculator. But I actually have a little bit of a problem with this question because 3 of them are repeating decimals. It just depends how far out you carry the division. So I don't really like this question. I think it's not a fair question. So the first one to figure out, you would do 25 divided by 48. And like I said, you can do that on a calculator. I did it over here using long division. And I just kept carrying out these decimal places, and eventually I did start to get a repeating decimal. These 3's keep repeating. So this, letter A, is a repeating decimal once you get to a certain point. For letter B, this one you would put in your calculator 11 divided by 40. And so I did that one here. And this one is what we call terminating. This one does terminate. So once you get to the 275, I didn't finish this, but 5 times 40 is 200. And so there would be nothing left. So this division, this fraction, does stop at 0.275. So this one is not a repeating decimal. For C, you would put in your calculator 7 divided by 32, and I did that one over here. And this one, again, if you carry this out far enough, it will start to repeat. You end up with 4 point, and then it's 5, 7, 1, 4, 2, 8. And then you get back to the 5 and it repeats again. It actually goes 5, 7, 1, 4, 2, 8. 5, 7, 1, 4, 2, 8. So this actually is also a repeating decimal. And then for letter D, which is the one I really think they wanted you to pick because it repeats much faster, in your calculator you would push 3 divided by 25. And so I did that one here. And when you do 3 divided by 25, you very quickly see the decimal repeating. It ends up at 8.33333333, and that 3 just keeps repeating. So I think they wanted you to choose this one, and they didn't expect you to do long division all the way out to this digit, or go far enough that you see that all these digits, the 5, 7, 1, 4, 2, 8, all repeat. But it is a misleading question because 3 out of the 4 do end up with repeating decimals. For question 14, the top students in a distance throwing competition are shown in the table. How many yards did the winner throw the ball? So the winner would obviously be the greatest number of feet, which would be Fernando. 175 is the greatest number. But what they're asking you is how many yards did Fernando throw? Fernando with the greatest number. So you have to know that there are 3 feet in 1 yard. So to figure out how many yards it is, you have to take the 175 and divide it into groups of 3 feet, because every 3 feet will be 1 yard. So let's do that. And so I'm looking at the answer choices. I could put a decimal here and I could continue to work on this, but I'm looking right now and I see that they're just using a fraction. So I'm going to do the same thing. Take the 1, bring it up 1/3. So 58 and 1/3. That's how many yards Fernando threw. For number 15, define a variable and write an expression to represent the following phrase. So 7 years younger than Lisa. This doesn't ask for a let statement, but I'm going to write one just to practice with you. So I'm going to say let x equal Lisa's age. And then I'm going to figure out what this sentence is saying. So 7 years younger than Lisa. So when you hear younger, you're thinking subtract, to take away, to make the number smaller. But remember when we see that word than, that's a key word that tells us we need to take Lisa, that's at the end, and move it to the beginning. So for 7 years younger, we want to think -7. Lisa, I just defined, I said Lisa's age is going to be X. So when you look at it, it looks like 7 minus X, but it's not. Remember that word than means take Lisa, take what's at the end, move it to the beginning. So we would actually say Lisa's age, X minus 7. This is now 7 years younger than Lisa. For number 16, Mrs. Rome has 2/3 of a pan of lasagna left after dinner. She wants to divide the leftover lasagna into 4 equal servings. So she wants to take 2/3 of the lasagna and divide it into 4 servings. So this is dividing fractions. So remember, you say keep, switch, flip. So keep the first fraction, switch the division to multiplication, and then flip this second number, this second fraction. So 4 is 4/1. So when you flip, you end up with 1/4. When you multiply, you get 2 times 1 is 2, 3 times 4 is 12, and you'll notice that 2/12 is not a choice, but if you simplify, you divide both numbers by 2, you get 1/6, and that is a choice. So 1/6 of the lasagna is what she is serving. Jeff is making fruit punch for the school dance. He needs 3 3/4 cups of pineapple juice per batch. If he wants to make 4 1/2 batches of punch, how many cups of pineapple juice would he need? So think of it this way, because these are difficult with the fractions, but if he's making 1 batch and he needs 3 3/4 cups of pineapple juice, let's say he wants to double it. He wants to make 2 batches. You would just take this, you would double that. You would do times 2. If he wants to make 3 batches, you would do times 3, 4 batches times 4. So when he wants to make 4 1/2 batches, you just multiply by 4 1/2. So it's 3 3/4 times 4 1/2. And so now there's a little bit of work to do. You can't multiply mixed numbers. You have to change them to improper fractions, or a fraction that's greater than 1. So you multiply. 4 times 3 is 12. 12 plus 3 is 15. And then the denominator stays the same, 15/4 times, change this as well. 2 times 4 is 8. 8 plus 1 more is 9. So 9 halves. And now you multiply. 9 times 15 is 135, I think. And then 4 times 2 is 8. So 135 eighths. But if you look, these are mixed numbers again. So we're going to need to divide this and get a mixed number. So 135 divided by 8. 8 goes into 13. It does not go into 1. It goes into 13 once. Bring down the 5, 55. Let's see, 6 times. I'm going to move over here, times 48. Or I'm sorry, minus 48. And so that is 7. And so since we now go to a fraction, I don't need to add to this. I have 7 left. So I use the 8 and I make it 7/8. So 16 7/8, which is choice I. And then for number 18, you can see I actually already started this one also. They're asking you which symbol to put in between here when you compare these numbers, 11/12 and then 0.91666 with that repeating 6. So is it plus, is it equal, is it less than or greater than? And so one's a fraction, one's a decimal, what you need to do is you need to make them the same. So the easiest thing to do is take the fraction and convert it to a decimal by dividing. So I went ahead, I did that ahead of time on the calculator. And so when you divide 11 divided by 12, it is exactly the same thing that they have here. And so the correct sign to choose would be equal.